So statistics, and this is some stuff that we've learned like since elementary school. I'm not even going to really go over the bar graphs, the circle graphs. I don't know. Yeah, you know what bar graphs are, right? You know how to read them. That's like pretty common sense. Remember in circle graphs, there's 360 degrees in a circle. So I usually do a thing in class where I'll say, okay, well, there's 30 kids, and how many of us are wearing jeans? So let's just say for the sake of argument, 15 kids were wearing jeans. Well, that's half the class, right? So that's 180 degrees of the circle graph, right? And so that would be like 50% of the kids. So if North has, let's say, 1,300 students, you would say that about 650 were wearing jeans. Like, it's just like common sense, right? Line plots is where they have something like, oh, I usually use the example of the Olympics, gold, silver, bronze, how many medals? Oh, okay, and they'll put like X's, right, on this line plot to kind of show how many medals we have. Stem and leaf plot always works best with grades. Like, let's say we gave a test and someone got 100. We would put that as a stem of 10 and a leaf of 100 to be 100%. And a 98% would look like that, or a 97, or a 96, or an 82, or a 77. It's just a way to organize the data so you can have all the numbers in order and it doesn't take up so much space. I'm sure you remember mean, median, mode. Mean is the average, right, where you find, you add all the numbers and divide by the number of numbers. The median is the physical middle number when you have those numbers in order. If there's two middles, we add and divide by 2. So like here, I guess the median would be 30. Mode, M-O, stands for most often. So it's the number that repeats the most often. So here the mode is 21. And I'm not even going to do the mean, add the numbers, divide by the number of numbers. The main thing we want to go over today, though, is the measures of variation. Do you remember what the range is? Range is the highest number minus the lowest number. It's always nice when the numbers are put in order. So like here, the range would be 7. Median, we know, is the middle number. And so here there's an odd number of even number of numbers, right? So the median then would be right in between those two, or 4.5. So the median doesn't have to be. Lower quartile is basically the median of the lower half. So this is the median of the lower half. So the median of the lower half here would be, if I'm just looking at those numbers, 1, 2, 3, 4, isn't the median of the lower half 2.5? And then the upper quartile is the median of the upper half. So the median of the upper half would be 6.5. And by the way, sometimes we call the lower quartile the LQ and the upper quartile the UQ. The interquartile range is the upper quartile minus the lower quartile, or in this case, 6.5 minus 2.5, or 4. Outliers are a little bit tricky, and there's a formula for it. The outliers are either too big or too small for the data set. So the formula is you take the upper quartile plus 1.5 times the IQR. And if anything is greater than or equal to that number, it would be considered an outlier. Oops, I did that wrong. Greater than or equal to. And if it's less than or equal to the lower quartile minus 1.5 IQR, then it's also considered an outlier. So for this particular example, we would have the upper quartile 6.5 plus 1.5 times 4. So this is any number bigger than or equal to 12.5, or on the low side, we take the lower quartile minus 1.5 times the interquartile range. So anything less than or equal to negative 3.5. Now we didn't have that in the data set because it just went from 1 through 8. But if this had been like an 18, let's say, for example, then that would have been considered an outlier. I'm going to run through the same things with this data set. So in this data set, it's an odd number of numbers. So we have the median actually as one of our numbers, which is 5. Our lower quartile would be 2.5, median of the lower half. Median of the upper half would be 7.5. And that gives me an interquartile range of 5, right? in between those two. If I want to put my outliers in, my upper fence would be 7.5 plus 1.5 times the interquartile range, so anything greater than or equal to 15. And on the lower side, 2.5 minus 1.5 times the interquartile range, so anything less than or equal to -5. And again, I didn't have any outliers, but if this had been like a 19, that would have qualified for an outlier. Even if it was a 15, anything on the line, so to speak, counts. All right, last thing is box and whisker. You did this in middle school. There's different values, I guess, that go with each spot. So the first dot here is always the lowest number. The start of the rectangle is your lower quartile. This, which is not always in the middle, by the way, but it's your median. End of the rectangle is the upper quartile. Then we have the highest number that's not an outlier, which if we don't have any outliers, it's just the highest number. And then if you do have an outlier, it's just kind of outlying here and not connected. And you'll see this on the homework. It's just a way to organize the data that you can visually see a little bit more where the median and the lower and upper quartiles are. So that is all the measures of variation and central tendency and data.